All right, let's look at example 6. I have that f of x is equal to negative a half x times x plus 3 times x minus 1 squared. All right, first, end behavior. How do I do that? First, I need to find the degree. Well, this thing is not all multiplied out. It's got parentheses in it, so I have to deal with that first. All right, well, let's see here. It's one here would become negative 1 half x. Well, the one in the middle is just an x, so it's going to multiply an x, and the one on the very end is an x squared. So what is negative 1 half x times x squared? Well, that ends up being negative 1 half x to the 4th power. Knowing that, what's the degree of this function? Well, the degree would be 4, which makes it even. What is the leading coefficient? What's the number in front of that x? Well, my leading coefficient is going to be negative a half, which is negative. So what happens with a leading coefficient that's even and negative? Well, that, if we go back and look, would be down both left and right. Down and down. Evens, remember, go in the same directions. Odds are opposite. So O and O. Odds are opposite, evens in the same behavior. X-intercepts. What are the x-intercepts? Well, remember you find those by setting the function equal to 0 and solving for x. Now the reason that I did not want you to multiply this out is if you did actually multiply this out, the next step is to factor. So you'd be wasting time. So never multiply it out more than we did up here. So what do I need to do? I set each one of these factors equal to 0 and I solve them for x. So I have negative 1 half x equals 0, x plus 3 equals 0, and x minus 1 raised to the 2nd power is equal to 0. Solving for x over here, if I multiply both sides by the reciprocal, which is negative 2 over 1, I end up with x is equal to 0. Well, how many times is 0 a 0? Well, remember, if I wanted to, I could put a 1 next to that x, so it only occurred once. So my multiplicity for 0 is 1. What about x plus 3 equals 0? If I solve for x by subtracting 3 from both sides, I get x is equal to negative 3. Well, what is a multiplicity of negative 3? Well, remember, if I wanted to, I could put parentheses and put a 1 here, so x plus 3 only occurs once. The multiplicity of x plus 3 is 1. Last one, if I solve it, let's say I take the square root of both sides to solve this, then I get that x minus 1 is equal to 0. I don't put plus or minus because remember 0 is not positive or negative. Solve for x is equal to 1. Well, how many times is 1 a 0 for this function? Well, it was in the format x minus 1 raised to the 2nd power equals 0. What does that mean? I could have, if I wanted to, and just to let you know, I'm going to write this down in the erase hit, but if I wanted to, I could have put this as x minus 1 times x minus 1 is equal to 0. Well, how many times would I have gotten an answer of x equal 1? Twice. So I have a multiplicity of 2. So what does that mean? Let's actually write down what that means this time before we move on to find the y-intercept. So if 0 has a multiplicity of 1, I need to cross the x-axis at that point. If negative 3 has a multiplicity of 1, I need to cross that x-axis at that point. If 1 has a multiplicity of 2, I need to bounce at the x-axis at that point. Y-intercept. How do you find the y-intercept? That's going to be your favorite part. Compute f of 0. So what does that mean to us? It means negative 1 half. Instead of writing x, I write times 0 plus 3 times 0 minus 1 squared. Negative 1 half times 0 is 0. 0 plus 3 is 3. And then negative 1 squared is 1, but it doesn't really matter because 0 times anything is 0. So my y-intercept here is 0. Well, there's all my information. So what do we do to graph these things? After we find it, first, plot all your points. What are my points? My points are 0, negative 3, 1, and, well, 0 is going to be the same. So I really only have 3 points, 0, negative 3, and 1. So let's plot those 3 points. All right, again, here's 0, here's negative 3, and here is 1. So then, what do we need to do? We need to put our end behavior at the end points, right? So at the very far left point, I better look like this. I better be going down to the left. At the very right point, I better look like this. I better be going down to the right. I go down to the right. So again, plot the points and find the furthest left. Use the end behavior on that point. Find the furthest right, use the end behavior on that. Then the multiplicity and connect the dots tells us what happens in the middle. So I'm here at this dot here because again, we read left to right, we write left to right, we graph left to right. So I'm at my left point. What's supposed to happen? Well, at negative 3, I need to cross. So since I'm below the x-axis, now I need to go above the x-axis. But we need to connect the dots because that's what we're told to do. So we go to the next point. So then here I am at 0. What happens at 0? 0, I need to cross. So cross the x-axis at that point. All right, play connect the dots, get to your next point. What is this point? This point is 1. What happens at 1? I bounce. And if you look at this, didn't I touch and turn around? So when you cross, you go from one side of the x-axis to the other. You go from one side of the x-axis to the other. When you bounce, you touch and you turn around. Which way do you touch and turn around? It depends. It depends on which way you were going. So see, I came in from the bottom, so I need to go back down the bottom. If I'm coming in from the top, kind of like we had on the example I gave here that was already graphed for you, see, I came in from the top, turned around, went back up. So the bouncing depends on which way you were coming in from. This happens to be I was going in from the bottom, so I need to go back down. This here is the graph of my function negative 1/2 x times x plus 3 times x minus 1 squared. Next one, x to the fourth plus 6x cubed plus 9x squared. Well, I'm all multiplied out. Great. So I don't need to handle that, but I need to find my degree and the leading coefficient. What's the degree? Well, the highest exponent is 4, so that means I have a nice even degree. What about the leading coefficient? What about the number in front of x to the fourth? There's nothing there, so that's a 1. 1's positive. So I need to figure out what happens if I have an even degree and positive. Remember, evens go in the same direction, either both up or both down. I'm positive, I'm going both up. So odds, opposites, even, the same. X-intercepts. What do I need to do? I need to set this thing equal to 0 and solve for x. So x to the fourth plus 6x cubed plus 9x squared equals 0. I need to solve it. Well, how do I solve it? Factor. What's the first step in factoring? GCF. Do I have a GCF? I do. It's x squared. Factor out your x squared and see what you're left with. What I'd be left with an x squared plus 6x plus 9. Can't factor x squared, but can I factor this thing right here? I can. That actually factors as x plus 3 times x plus 3. What's another way of writing x plus 3 times x plus 3? That's the same as saying x plus 3 squared, right? Well, I need to solve both of these. I'm just going to move myself up here because I'm going to run out of room. So x squared is equal to 0, and x plus 3 quantity squared is equal to 0. Solving, here I get that x is equal to 0. And over here, I get x plus 3 is equal to 0, and x is equal to negative 3. So I have two zeros. One of them is 0, and the other one is negative 3. Well, what is the multiplicity of 0? How many times is 0 a 0 for this function? Well, it was x squared, right? Couldn't I write x times x equals 0? Yeah, so how many times are you a 0 at that point? What are you raised to when you're equal to 0? 2. So you have a multiplicity of 2. So my x-intercept of 0 has a multiplicity of 2. What does that mean? Hey, I need a bounce at that point. What about negative 3? Well, again, if you look here, x plus 3 squared equals 0. So what is that telling us? Well, that's telling us that we have a multiplicity equal to 2 because I'm being squared and I'm equal to 0. So negative 3 has a multiplicity of 2, which again means I need to bounce. Next one, y-intercept, our favorite because it's plug and chug, right? So we got 0 to the fourth plus 6 times 0 cubed plus 9 times 0 squared. So basically we have 0 plus 0 plus 0, which is 0. Next, plot all your points. Well, what were my points? 0, negative 3, 0. So really I only have two of them. One of them is 0, and the other one is negative 3. Then what do you got to do? Put your end behavior on these points. So to the very left, what am I supposed to do? Go up. To the very right, what am I supposed to do? Go up. Now use your multiplicity and the fact that you know you need to connect the dots to get the rest of your graph. So start at negative 3. What am I supposed to do at negative 3? I bounce. I was coming in here from the top, so I touch at that point. I got to go right back up. So you bounce depending on which way you come in. Notice I was coming in this way, so I got to turn myself back up. But then I got to play connect the dots, go down to the other dot. All right, well, what am I supposed to do at 0? Well, if I look here, I'm supposed to bounce. Did I bounce? Yeah, because I already drew the end behavior there, and it shows me bouncing. So I came in and then touched and turned around. So this thing here is the graph of x to the fourth plus 6x cubed plus 9x squared. All right, last one, negative x cubed minus x squared plus 4x plus 4. Same thing, different numbers. All right, step one, degree leading coefficient. What's the degree of this function? I'm all multiplied out. It's 3. 3 is odd. Leading coefficient, number in front of x cubed, there's a negative there, so my leading coefficient is negative. What happens when your leading coefficient is negative and your degree is odd? Odd is opposites. So when it's negative and odd, it goes up left, down right. X-intercepts. So set this thing equal to 0 and factor. Negative x cubed minus x squared plus 4x plus 4 equals 0. How do I factor that? Got 4 terms? Try factoring by grouping. So I draw a little curtain there. Let's see what's going on here. If I pull out a negative x squared from the first 2 terms, what's left? Well, it would be a positive x plus 1. From the next 2 terms, if I pull out a positive 4, what's left? I'd be left with x plus 1. Well, I generated the same binomial when I did my grouping. So then I have x plus 1 times negative x squared plus 4 equals 0. Solve both of these. X plus 1 equals 0. Negative x squared plus 4 equals 0. Over here, if I solve, x is equal to negative 1. So I have negative 1. How many times did this thing occur in this polynomial? 1 time. I have a multiplicity of 1, which means cross the x-axis at that point. Let's figure out the other one. I have negative x squared plus 4. So if I solve for x, move 4 to the other side, I get negative x squared is equal to negative 4. I have to get rid of my negative, so divide both sides by negative 1. Move up this way. Positive x squared now is equal to positive 4. Take the square root of both sides to solve this thing, and x is equal to plus or minus 2. Because when you take the square root of something to solve, you write plus or minus. Only time you don't do that is if it's equal to 0, because again, 0 is neither positive nor negative. How many zeros do I got there? I got 2 of them. One of them is the number 2, and then the other one is the number negative 2. Well, what's the multiplicity of these things? Well, remember, this is not equal to 0. This is equal to 4. So really, if I put it back this way and had it equal to 0, I could have factored it as x minus 2 and x plus 2, set each one of those equal to 0. So they both only have a multiplicity of 1. Because remember, this only tells you the multiplicity if the number over here is 0, and 4 is not 0. So that means, again, that 2 has a multiplicity of 1, so I cross the x-axis at that point. And negative 2 has a multiplicity of 1, so I cross the x-axis at that point. Finally, computing f of 0. So f of 0 is negative 0 cubed minus 0 squared plus 4 times 0 plus 4. So basically, this is saying if I take 0, subtract 0, add 0, and add 4 to it, I'm going to get 4. So we got there. We need a graph. We filled out everything. We need a graph. What do we do? Well, plot our points. How many points do I have? Happen to have 4 to plot this time. So let's say I have the point negative 1 right here, the point positive 2 that's over here, the point negative 2 that's over here, and then I have the point 4. Stick your end behavior on. So what's the furthest left I go? The furthest left I go is over here at negative 2. I need to go up. What's the furthest right I'm going? Well, the furthest right I'm going is at positive 2, and I need to go down. So my end behavior's on there. Now it's all up to multiplicity and the fact that I know I need to connect the dots to get me the rest of the way. So what am I supposed to do at this dot here at negative 2? Negative 2, I need to cross the x-axis. So I need to cross the x-axis. But I'm playing connect the dots. So connect your dot, get to the next point. All right, well, what dot is that? Well, that's negative 1. What do I do at negative 1? At negative 1, I need to cross the x-axis, but I need to play connect the dots. Y-intercepts don't have multiplicity, so just keep trying to connect the dots. Get down to the next one. Okay, well, what point was that? That's the point 2. What am I supposed to do at 2? I need to cross. Did I cross the x-axis at that point? Yes, I did. So this thing here is the graph of my negative x cubed minus x squared plus 4x plus 4. That's it for graphs of higher degree polynomial functions.